So, I welcome you to discussion on acid-base concepts. As everybody knows that in world concepts, an acid is essentially that which is a sour to taste. For God's sake, don't see the taste of any acid. Nowadays, nobody is seeing taste of chemicals. It is a very, very old idea. Anything that is sour to taste, anything that turns blue litmus to red color. What is litmus? Litmus is a plant leaf extract. That leaf extract solution has a property to get itself converted into red color if the solution is acidic, if you add it to it. And then acid essentially reacts with active metals. You know what is active metal? Sodium, potassium, calcium, magnesium, aluminum. Gold is not active, mind. Acids react with active metals to give hydrogen gas, and they react with the bases to give salt and water. A typical example of acid, gastric juice. I am suffering from hyperacidity. Many times people say it is sore, belching, burning in the heart. There is in stomach actually, 1.5 liters. That is, you normally buy a packet of milk in the early morning. Each packet is generally half liter. So 3 packets, 1.5 liter of acid, hydrochloric acid is produced in our stomach every day. Naturally, you'll ask me a question then why our stomach is not getting burnt. There's a different idea. Stomach is not getting burnt because there is a mucous membrane. But if you have a bad habit of smoking cigarettes, cigarette smoke can attack that mucous membrane, and due to which you can suffer from burn injuries in the stomach and all that. This causes so many problems about that I can't discuss now. At the moment, I'm saying don't smoke cigarettes. That's not good for you. Don't worry much. If you worry much, you can get hyperacidity. Worry and tension will trigger the generation of acid in stomach. Anyway, hydrochloric acid is produced in stomach. Lemons and oranges contain citric acid and also ascorbic acid. Tamarind juice contain tartaric acid. These are all acids. And bases, base is anything which is generally caustic to taste, soapy to touch. That turn red, it must blue color. Your sodium hydroxide caustic soda is a very well-known example with which you make soaps. Sodium bicarbonate, that is a baking soda. These are all typical bases we know. But in our syllabus, if we look at, we have Arrhenius acid-base theory. We have Arrhenius acid-base theory followed by Lowry Bronsted and Lewis. Before we go to this, just we quickly look at any material if you dissolve in water, if it allows the passage of electric current through it, that is called electrolyte. If you dissolve sugar in water, urea in water, glucose in water, it never allows the passage of current, they can't make electrolytes. Electrolyte is essentially a solution that allows the passage of electric current. Sometimes, all solutions of strong acids, strong bases, salt solutions, all these are electrolytes. Fundamentally, if I dissolve some salt in water, the salt originally contains Na plus Cl minus ions which get separated, and that conducts current. Anything that has freely movable ions can allow the passage of current through it. It's a good conductor. If I dissolve acetic acid in water, acetic acid is basically a molecular substance that is not originally containing ions, but in water aqueous solution it breaks to give a few acetate ions and H plus or actually H3O plus ions. 5% it dissociates. So that acetic acid, which is ionizing by 5% in aqueous solution, is a weak electrolyte. Weak electrolyte ionizes less, strong electrolyte ionizes more. Now, all strong acids, all strong bases, and the salts made by either a strong acid or by a strong base or by both is a strong electrolyte. Coming back, a strong electrolyte produces large number of ions. We say its degree of dissociation is more. A weak electrolyte ionizes to a less extent. Degree of dissociation is less. Acetic acid is 5%. Now, quickly we look at Arrhenius acid base theory. Any substance that dissolves in water and breaks down itself into H plus ions, let negative ion be anything, along with any other negative ion, is called as an acid. Your HCl, HNO3, H2S04, whenever you place them in water, they dissociate to give H plus ions and corresponding X minus ions. Anything that dissociates in water to give OH minus ions is a base, NaOH, KOH, so on. And reaction of acid base is called neutralization, and the neutralization gives acid plus base reaction that gives water and salt. See, any acid, any base reacts to give salt. For example, NaOH, HCl react to give NaCl plus water. NaCl is a common salt which we use in our day-to-day life. In day-to-day life, salt means NaCl, but in chemistry, salt means anything that forms by reaction of any acid and base. For example, NaOH and sulfuric acid will give Na2SO4, and Na2SO4 is a typical salt of strong acid and strong base. Acetic acid and NaOH reacts to give sodium acetate in water. Sodium acetate is a typical salt of strong base and a weak acid. There can be salts like formed from strong acid, strong base, or strong acid, weak base, or strong base, weak acid, or even weak acid, weak base. Don't worry. But these Arrhenius theory ideas are limited to aqueous solutions. And essentially, according to Arrhenius, it should break down to give H plus ion. Now, if you take a solution of aluminum chloride in water, definitely it is acidic, and you can add blue litmus, it turns to red color. But Arrhenius theory cannot say that it is an acid. And this theory is discarded because of limited scope. Traditionally, still we are using, but it is replaced by a better theory called Lowry-Bronsted theory. According to this theory, again, an acid is anything that can release H plus, that can break down to give H plus. And here a base is something that can take H plus. So proton giver is acid, proton acceptor is base. You can see HCl, again Arrhenius acid and Lowry-Bronsted acid also, because HCl can give H plus. Anything that gives H plus is acid, according to Lowry-Bronsted, according to Arrhenius. But a base, according to Arrhenius, should break down to give OH minus in water, whereas according to Lowry-Bronsted, a base should, if it is able to accept H plus, that is fine. Ammonia is a Lowry-Bronsted base because ammonia can take H plus to become ammonium ion. Ammonia per se is not a Arrhenius base because ammonia per se cannot break down to give OH minus ion. Well, now we are looking at another idea. What is the fate of an acid after giving H plus? If I put HCl in water, we can write an equilibrium. HCl plus water, you can put two arrows, gives H3O plus Cl minus. Try to write. You can write and you can see that when HCl is giving off H plus, it is acting like an acid because it is losing H plus, and the Cl minus produced is called conjugate base. Similarly, H2O, oxygen has two lone pairs on it, so it is able to accept a proton given by water to give H3O plus. H2O here is a Lowry-Bronsted base. H3O plus, which is formed by accepting proton, is called as its conjugate base. So H2O is a base because it is accepting proton. H3O plus is its conjugate acid. HCl is original acid. After losing H plus, the Cl minus it is giving is called its conjugate base. Therefore, every acid has a conjugate base. Every base has a conjugate acid. So try to see, from any molecule, try to remove a H plus, you get a conjugate base. For any material, if it has lone pair of electrons on the central atom, or if it has lone pair of electrons, it can take H plus. After gaining H plus, it gives its conjugate acid. Notice CH4 is not having any lone pair of electrons anywhere. So CH4 cannot be a Lowry Bronsted base because it can't take H plus. Even it is not giving H plus, so it is not even Lowry Bronsted acid. So this is the idea. If an acid is strong, remember, its conjugate base is weak. If the acid is weak, its conjugate acid is strong. So based on its ability, one can really see which is the strongest acid, which is weakest acid. Anything that can easily give H plus ion is a stronger acid. One can see that most powerful acid, if you look at perchloric acid, HClO4 is most powerful acid. Then you can arrange the acids, We will be coming back to this idea, proton concept, in detail a little later. But use your common sense. What is the conjugate base of hydrogen atom? If you want to have conjugate base, what you should do? You should remove H plus. So from hydrogen atom, if you remove H plus, what you are left with? You are left with an electron. Therefore, conjugate base of hydrogen atom itself is electron, theoretically speaking. Really, hydrogen atom cannot or may not act as an acid. That is different. Technically, if they ask a question, what is a conjugate base? Simply remove H plus from the given molecule or ion. If they ask you what is conjugate acid, simply add H plus. Acid means add, base means remove. If I give HCO3 minus ion, what is its conjugate acid? HCO3 minus, add H plus. You get H2CO3, that is conjugate acid. For the same HCO3 minus ion, what is conjugate base? Simply remove H plus. HCO3 minus gives H plus CO3 2 minus. That carbonate ion, CO3 2 minus ion, is its conjugate base. So always remember this. So we stop here. Please look at the post which I am making along with this in the comments. Thank you very much. Bye. Again, we'll meet while I talk about Lewis theory. Bye-bye.